Good morning, everyone. So, we are the group 13 and we will report about the global climate. So, first, this is our learning objectives. Relate global temperature and precipitation to geographical location. Analyze on how Earth's rotations affects global climate. And lastly, classify different climates using the Köppen system. So this is the introduction of our report. The long-term distribution of heat and precipitations of Earth's surface is called global climate. Astronomical variation and atmospheric shielding cause incoming solar radiation to fall unevenly on Earth's surface. Ocean current and wind further redistribute heat and moisture around the globe. It also create the global zone. So ang global zone have also characteristic annual precipitation, the temperature, the wind, and also the ocean's current pattern that together determine local and short-term weather. So it also affect to develop the ecological adapted suits of plants and animals, and of course, human. So changes in the astronomical, oceanographic, and of course, the atmospheric and geological factor that also determine the global climate that lead and global climate change over time. So, global climate is also refers or refer about the long-term patterns of temperature, humidity, wind, and of course the precipitations of particular region. The climate also refers the encompasses the average weather condition over an intended period. So typically 30 years or more, we are also experiencing the climate change. So climate also play a crucial role and also shaping the ecosystem and influencing the distribution of plants, animals, and other species, including the human. So the global climate is a complex group of astronomical, atmospheric, and geological and oceanographic factors accounts for Earth factor climate. So many of the factor vary naturally over decades, centuries, and millennia. Astronomical and geological variations begin in cascade of comparastory adjustments of coupled or link ocean atmospheric system, so which is turned on required major adjustment biological system. So this variation force changes in the global pattern for long-term precipitation and temperature of global climate change. So we have here three types of global climate temperatures and precipitation. So the first is the complex group of astronomical, atmospheric, geological, and oceanographic factor accounts for Earth's global climate. The second is astronomical and geological variation begin a cascade of um, compensatory judge adjustment and coupled or link. And the last is this. So this variation or this global climate temperatures also changes in the global pattern of long-term precipitations and the temperatures of global climate change. So we have here a global precipitation. So ang global precipitations also refers about distribution of water or any various form falling down from the atmosphere into the Earth's surface. So that is the precipitation. So this also includes about rain, ano pa ba? The snow, the sleet, or sometimes hail. So ang precipitations also pattern are influenced by factor like atmospheric circulation, temperatures, and topography. So understanding global precipitation is also vital assessing water resources, agricultural productivity, and also the impact of global or climate change. So it also having a relationship to the areas of rising and sinking air. So in this picture, kung nakikita natin, it is an um, presentation about yung maraming ulan na nararanasan natin in every year. So that is includes about yung baha na nararanasan kapag umuulan or yung mga putik natatapakan natin kapag umuulan. So that is a good sample na nakikita natin in this picture. So, ang precipitation is an also abundant where the air rises and then abundant where the sinking. So, dito po. So, precipitation can also have wide ranges effect on human well-being and ecosystem. So mga rainfall, snowfall, and also the time of snow melt can also affect amount the surface water and ground available in drinking, irrigation, and industry. So based on the satellite and the picture kung nakikita natin is an observation about the ground-based measurement, also about the essential tools for monitoring and analyzing precipitation trends of global scale. So it is meron siyang pattern and of course meron din siyang um, dito natin nakikita yung temperature, yung atmospheric circulation, and topography. So that's all. Next reporter. Oh,
Factors affecting precipitation. First, equator and latitude, evaporation, wind, humidity, pressure, and temperature. Meteorologists predict and explain precipitation patterns by understanding interplay of factors which can alter local and global weather patterns affecting the amount and the type of precipitation. Astronomical factors affecting global climate change. Energy from the sun drives the Earth's climate. Changes that affect the amount of solar radiation reaching the planet called insolation, and that alter the distribution of sunlight on its surface can cause global climate change. Earth's outer atmosphere receives about 2 calories of energy per square centimeter of area, a value known as the solar constant. In spite of its name, the solar constant varies over time. Earth's position with respect to the sun over time affect its climate. So the Earth's climate is influenced by solar energy with changes in insolation and pamamahagi ng sikat ng araw causing global climate change. The solar constant varies over time and Earth's position na may kaugnayan naman sa sun also impact the climate. Astronomical factors affecting global climate change. The planet receives about 6% more solar energy in January than in July. The Earth's axis, aligned through the poles, is tilted 23.4 degrees with respect to the Sun. The Sun's rays strike the northern hemisphere most directly on June 21st, the summer solstice, and the southern hemisphere most directly in December 21st, the winter solstice. The equinoxes on April 21st and September 21st mark the dates when the sun shines directly on the equator, and day and night are the same length around the globe. Orbital geometry and axial tilt together determine the Earth's pattern of seasons. The word solstice is the point where the sun appears to reach either its highest or lowest point in the sky for the year, while equinoxes is the time of equal days and nights. It means the Earth receives 6% more solar energy in January than in July. Its axis tilted 23.4 degrees with the sun. The sun's rays strike the northern and southern hemispheres most directly on June and December solstice. So astronomical factors play a significant role in shaping global climate over time scales. Two primary astronomical factors are Earth's orbit around the Sun and its axial tilt. Understanding these astronomical factors is essential for comprehending the Earth's climatic history and predicting long-term climate trends. Geological factors affecting global climate. Geological changes on Earth's surface can also affect global climate. The distribution of continental land masses and ocean basins affect the patterns of global atmospheric and oceanographic circulation, and the shape or topography of Earth's surface directs wind and ocean currents. According to the widely accepted and well-supported theory of plate tectonics, the continents move, ocean basins open and close, and mountain ranges form over time. Geological factors affect global climate. So, geological changes on Earth's surface impact global climate, atmospheric circulation, and topography. Plate tectonic theory suggests continents more, that the ocean basins ay nagsasara at nagbubukas. And lastly, the mountain ranges form over time. So, understanding these geological factors is crucial for reconstructing past climate, predicting future climate changes, and interpreting the complex interactions between Earth surface processes and atmosphere over geological timescale.
The global climate patterns. Earth's climate zones are classified according to their average temperature and rainfall accumulation, and in general form latitudinal east-west oriented bands on Earth's surface. Earth climate zones is classified base sa temperatura at rainfall on how much rain has fallen or will fall in total. Average temperature increase with latitude and decrease with altitude. Temperature are highest near the equator and near sea level. At the equator, when the sun rays are most direct, this is where temperature are highest latitudes. The sun rays are less direct. Pag malayo yung area from the equator, the lower its temperature. These patterns of uneven heating drives convection or heat-driven circulation of the oceans and atmosphere. Warm, moisture-laden air at the equator rises and flows toward the poles, cooling and releasing precipitation and sinking as it flows. The German climatologist Vladimir Köppen (1846 to 1940) developed the most common classification nomenclature of climate zones in the early 1900s. The Köppen system recognized 5 general types of regional climate based on the average temperature and precipitation: humid tropical, dry humid mid-latitude with mild winters, humid mid-latitude with cold winters, and polar. Most widely used and recognized climate classification system in geography for many decades. Most revised climate classification system are based on Dr. Kappen's initial system. Different climate using the Köppen system, which consists of 5 climate types. First is a tropical or megathermal climate, are characterized as having constant warm temperature. It is the lowest mean monthly temperature is greater than 18 degrees Celsius. These regions have a high moisture index and support rich vegetation all year. Megathermal climates include the Amazon basin, many islands in Southeast Asia such as New Guinea and the Philippines, and the Congo Basin in Africa. Megathermal climates is classified into two, which is the tropical monsoon AM and the tropical wet and dry or savanna climate or AW. In tropical monsoon AM, its climate has a very low precipitation for 1 to 2 months. Each year, rainforests grow here because the dry period is short and the trees survive of soil moisture. This climate is found where the monsoon winds blow, primarily in southern Asia, western Africa, and northeastern South America. There is also another scenario under which some places fit into category. This refers to the trade wind littoral climate because easterly winds bring enough Precipitation during the winter months to prevent the climate from becoming tropical wet and dry climate. Tropical wet and dry or savanna climate. The tropical wet and dry climate lies between about 5° and 20° latitude around the location of ITZZ. In the summer where the ITCZ drift northward, the zone is wet, and the winter moves toward the equator, the region is dry. The climate exists when strong monsoon winds blow from the land to sea.
Current climate in Köppen system is dry climate. Dry climate, it is the region that have dry climate receive very low rainfall or precipitation. Dry climate regions exist between 15 to 60 degree north and south of the equator. So this region, the rate of evaporation is higher than precipitation. So dry climate divided into two. The first is arid region or desert climate, and the second is semi-arid region, partially dry. So where the evaporation exceeds precipitation faces scarcity of water. It happens due to high temperature. When the high temperature increases the capacity of the air to hold the water. So the amount of moisture of the soil causes the growth and develop of the vegetation in the region. Third is temperate climate, are located between tropical climates and the Earth's poles. Temperate climates usually have four seasons: summer, fall, winter, and spring. The temperature can change a lot day to day and also from season to season. It may snow in the winter and it get as 40 degrees Celsius in summer precipitation, and it is lower than in tropical climate, but it may rain throughout the year.
Continental or microthermal climates. Continental or microthermal climates have not summers and cold winters, occurring typically at the interior of continent. Continental and microthermal climates are both types of climates that are cold winters and warm hot summers. However, there are some differences between the two. Continental climates refers to a climate type that is found in the interior regions and continents away from the moderating influence of large bodies of water. It is typically characterized by a wide range of temperature throughout the year, with cold winters and hot summers. The temperature between summers and winter can be quite significant. Microthermal climates refers to a subtype of continental climate that is typically found in higher latitude and higher elevations. It is characterized by even colder winters and shorter, cooler summers compared to a typical continental climate. The temperature range in microthermal climate is usually great, with very cold temperatures in winter and the relatively cool temperatures in summer. Both continental and microthermal climates can have diverse vegetation and ecosystems depending on factors such as latitude, elevation, and these climates can be found in various regions and the around the world, including parts of North America, Europe, and Asia. Polar or alpine climates. Polar or alpine climates sustain consistent cold temperature throughout the year. Polar and alpine climates are both characterized by extremely cold temperatures, but there are some differences between the two. Polar climates, also known as tundra climates, are found near the Earth poles such as the Arctic and Antarctica. These regions experience long bitterly cold winters and short cool summers. The average annual temperature in polar climates are consistently below freezing. Alpine climates are found in high mountains region around the world. These climates are cold temperatures and high degree of variability. Alpine climates experience cool to cold summers and extremely cold winters. The temperature can change rapidly in alpine region, and the higher the elevation, the colder climate. While both polar and alpine climates are cold, polar climates are typically found in Earth's polar regions and have consistently low temperature, while alpine climates are found in high mountain region and have more variability in temperature. So that would be all for our group presentation, week 13, Global Climate. Thank you.